Okay, today I want to talk about review for chapter 6 today. This is like outline. This is like all the chapter 6. This is the first example. Find the inverse function of f of x equals 2x minus 3 minus ln of x plus 1. How can you find the inverse function? We can follow this one. Step 1. Write y equals f of x. So we have y equals the ln of 2x minus 3 minus ln of x plus 1. Because the f of x is exactly same to ln of 2x minus 3 ln x plus 1. The next, could you like combine this one? Do you know this one? Do you know how can you combine? Do you know? Could you run your answer? Was it like yes, this is exactly, yeah, it's good, thanks. Ln of x of y. So we have, this is ln of 2x minus 3 over x plus 1. We can change like this. Step 2, solve this equation for x in terms of y. So how can you solve this equation? First, I want to eliminate ln. So you take e. So it's gone, like this. So we have e to the y equals the 2x minus 3 over x plus 1. The next, multiply the both sides by denominator x plus 1. Cross out, distribute e to the y. So we have x times e to the y plus e to the y equals 2x minus 3. The next, you just only isolate x terms on one side. We have 2x terms here and here. So I'm going to move this one to the other side. Subtract this one. So what happens is it cancelled. You have to move negative 3 to the other side. You add 3 to the both sides. So we have this one. This right hand side is the 2x minus x times e to the y. So we have the 2x minus x times e to the y equals. The left-hand side is e to the y plus 3. So we have e to the y plus 3. The next, you can factor out common factor x. The factor out x. 2 minus e to the y equals e to the y plus 3. Next, divide the both sides by the coefficient of x, 2 minus e to the y. So like this, cross out. So we have this result. X equals e to the y plus 3 over 2 minus e to the y. So we have this result. This is like a step 2. Like this. Step 3. Interchange x and y. What does it mean? You can replace x by y, y by x. So that's it. Interchange x and y. So we have this result. So that's it. This is the whole idea for solving this problem. Second one. If f of x equals 10 over pi x plus sine x plus cosine x, find inverse f prime of 6. So, do you remember? So how can you solve this problem? So we have one good theorem. What's it like a theorem? The theorem is like this. The function f is 1 to 1. and f prime of f inverse of a is not equal to 0. What's the conclusion? Inverse function prime at a is 1 over f prime of inverse function at a. So this is like exact theorem. I don't use it. The first, you can check function f is 1 to 1 or not. So check f is 1 to 1. Take f prime of x. F prime of x is 10 pi x prime is 10 over pi x prime is 10 over pi. Sine x prime is cosine. Cosine x prime is negative sine. So what's that? So this is exactly greater than 2. So cosine x is always between -1 and 1. Sine x is between -1 and 1. So what does it mean? This is always greater than 0 because the 2 -1 is like 0. So this number is greater than 2. This is the greater number, some the 10 over pi minus smallest number, negative 2 is always greater than 0. This is always positive. So what does it mean? Function f is increasing on minus infinity to infinity. The increasing function is always 1. Does it make sense? Function is like increasing. You can draw horizontal line. We have only one intersection point. Function is 1 to 1. We can use theorem. The first one, you can find inside one inverse f of 6. This is unknown x. You can use definition. This is the same to 6 equals f of x. What's it like f of x? F of x is given function. You plug into here. 6 equals 10 over pi x plus sine x plus cosine x. So let me see. What is x? What do you think? What is x? So do you know answer? You can check. What is x? So if you know answer, could you write your answer on the chatting board, please? So do you know what is x? You can guess the number. Pi over 2 is right. Pi over 2. Yes, pi over 2. You can plug pi over 2 into x. So what happens? I want to check. This is 6 equals 10 over pi times pi over 6. Sorry, pi over 2. Plus sine pi over 2. Plus cosine pi over 2. This is like exactly 6. Pi is crossed out. 2 is crossed out. Change 5. Plus sine pi over 2 is 1. Cosine pi over 2 is 0. So exactly 6 equals 6. Yes, we have it. So this is answer. X equals pi over 2. So next step. What's step 2? You plug pi over 2 into here. So what's that? We have 1 over f prime of pi over 2. You calculate f prime of pi over 2. Only plug pi over 2 into x. Here, you plug into pi over 2 here, like this. 10 over pi cosine pi over 2 minus sine pi over 2. This is same to cosine pi over 2 is 0. Same to 10 over pi minus sine pi over 2 is 1. You can change 10 over pi. 1 is the same to pi over pi. So we have 10 minus pi over pi. This is like step 2. You can find this one. Step 3, exactly reciprocal. You can plug this value into denominator. So we have this one, the reciprocal is pi over 10 minus pi. This is idea for solving second problem. Third one, so we think about limit problem. So if you want to solve limit of ln function, you need to draw graph of ln. The graph of ln is like this. So we can solve step by step. X value approaches 5 from the right. What happens inside 1 first? So you can plug 5 into here. So this is 5 squared minus 25 is like 0. The x value approaches 5 from the right. So this number is a little bit bigger. So one example is 5.1 square minus 25 greater than 0. What does it mean? Approach to 0 from the right. So like this. The inside one approach to 0 from the right. What happens at n function? What is the answer? So what do you think? The next one. The x squared minus 25 approach to 0 from the right. What is whole at n function? The negative infinity? Yes, negative infinity. The inside one approach to 0 from the right. What does it mean? Inside one is lower of x-axis. So this is approach 0 from the right. This ln function is going down, going to the negative infinity. So answer is minus infinity. Second one. This is like you can plug infinity into x. So what happens? Infinity minus infinity form. How can you solve? You can combine to the only one ln. Next, you can divide top one and bottom by the highest power term in the bottom one, like x. You can distribute 1 over x. 5 times 1 over x is 5x. X times 1 over x is equals to 1. The 1 over x times 2 is x over 2. The 1 over x times 3x is x is crossed out, only 3. So what happens? So x value approaches infinity. 5x is going to 0. 2 of x is going to 0. The remaining part is ln 1 over 3. ln 1 over 3 is ln of 1 minus ln of 3. What is ln of 1? Do you know what is ln of 1? The 0, is it right? 0? Yes, ln 1 is 0. Answer is minus ln of the 3. Is right? This is answer. Answer is minus ln of 3. So next one. Here. How can you solve this limit problem? We can draw graph of exponential function. The exponential function is graph like this, e to the x. So x value approaches 5. What happens? X minus 6 over x minus 5. You plug 5 into x. So we have 5 minus 6 over 5 minus 5. This answer is negative 1 over 0. So what does it mean? Minus 1 over 0 is 2 possible answers, infinity or negative infinity. You can decide. How can you decide? You can use one-side limit. Here, this is 5. X value approaches 5 from the right. X value approaches 5 from the right. I want to choose test number 5.1. You plug into x here. What's that? This is 5.1 minus 6 over 5.1 minus 5. Top one is negative. Bottom one is positive. Negative or positive is minus infinity. So like this, right? So what's it like e to the x minus 6, x minus 5? What's that? So what is the answer of this one? So do you know answer? Minus infinity? Is it right? So really be careful. X minus 6 minus 5 approach minus infinity. So exponent approach to minus infinity. The exponent approach to minus infinity. So approach to minus infinity. Load of x-axis. Was it like an exponential function? Exponential function is red one. The red one approach to the x-axis. Y value is 0. So really be careful. Answer is like 0. So next one. You can draw graph of arctangent. This is like a graph of arctangent. So same, step by step. X value approach infinity, what happens e to the x? So here, x value approaches positive infinity. Exponential function is going up, going to the positive infinity. Negative e to the x is take a negative sign, minus infinity. So what is arctangent minus e to the x? So what is the answer? So what do you think? So what is the answer? Yes, minus 5 2 is right. Yeah, this inside one approach to minus infinity. What happens after tangent? Here, inside one approach to negative infinity. Arctangent approach to like this. Arctangent approach to this horizontal asymptote negative 5 2. Answer is negative 5 2. Yeah, we have it. This is the answer. So one more. Do you know this one? You can try to solve this problem. Limit x value approaches like infinity. The what is 0.1 to the power x. What is the answer? So do you know this one? Do you know this one? So do you know graph of this one? What's it like a graph of a to the x? This is f of x equals a to the x. This base a is between 0. Yeah, it's good. Thanks. This is a is between 0 and 1. What's it like a graph of this one? The graph is like this. So x value approaches minus infinity. A to the x approaches 0. Answer is 0. So like this. You need to know some of the general exponential function, general logarithmic function. You have to know the both of them. Here, find the exact value of inverse cosine pi over 4. So do you know this one? Inverse cosine of x is exactly x. So for all x in the domain, is right? In the domain. Here, pi over 4 is, yes, in the domain. The pi over 4 is in the domain. So answer is like this one. Cross out pi over 4. Is it 5 pi over 4? What do you think? This is true or false? This is false because 5 pi over 4 is here. 5 pi over 4 is the greater than pi, the not in the domain. This is false. This is false. So how can you solve this problem? You have to move. You can find cosine 5 pi over 4 equals cosine of the different angle. So how can you do that? You can use this one. 5 pi over 4. This is like angle 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we have here. This angle is exactly 5 pi over 4. So what's like a cosine function? Cosine function is positive in first quadrant, negative in second quadrant, negative in third quadrant, positive in the first quadrant. We have some of the same sign is the second and third quadrant. You have to reflect this line about x-axis. When you reflect like this, you can find this angle. So this angle is exactly pi minus pi over 4. So we have 3 pi over 4. So what does it mean? 3 pi over 4. This is same. So we can use this idea. You can change it like this and take inverse cosine. The 3 pi over 4 is, yes, in the domain. Cancelled, we have it. This is the whole idea. It's good. So one more. What's the inverse sine of pi over 4? What is the answer? Answer is pi over 4, right? Because this is always true. You need to know the different domain. Inverse sine of x equal to x. What's like x? X is between negative pi over 2 and pi over 2, between these angles. So yes, cancelled, pi over 4. So one more. Inverse sine of 3 pi over 4. Is it right? This is true or false? This is false. Because, thank you, the 3 pi over 4 is not in the domain. Not in the domain? No. So you can use similar idea. Here, you can draw 3 pi over 4. Here, angle 3 pi over 4. So what's it like a sine function? Sine function is positive, negative. You have to reflect this segment about y-axis. We have it. So this angle is pi over 4. So how can you do that? Sine 3 pi over 4 is same to sine pi over 4. You can take inverse sine the both sides. The inverse sine the both sides cancelled. Answer is pi over 4. This is like a whole idea for solving this problem. The next thing, find the exact value of secant arcsine of 4 over 5. So how can you solve this problem? So we can use triangle in this case. First one, arcsine 4 over 5 is unknown. The arcsine 4 over 5 is unknown, angle theta. I want to use definition. This is same to what? 4 over 5 equals arc sine theta. Sorry, not arc. Here, erase. Only sine theta. The sine theta equals 4 over 5. You can draw triangle. The sine theta is 4 over 5, exactly opposite over hypotenuse. You can find adjacent by using Pythagorean theorem. So we have y square plus 4 square equals 5 square. You subtract 16 from both sides, cancelled. So we have y square equals 25 minus 16 is 9. Y equals 3. What's what? 3. The next thing, you plug this theta into here. This is same to secant theta. What is secant theta? 1 over cosine theta. What's like a cosine? Cosine theta is here. Adjacent over hypotenuse. Exactly 1 over 3 over 5. Flip 5 third. This is the whole idea. The next one. Here, similar. Inverse cosine of x over 3 unknown angle theta. Use definition. X over 3 equals cosine theta. You can draw triangle. So like this. Cosine theta is the adjacent over hypotenuse. You can find opposite by using Pythagorean theorem. X squared plus y squared equals 3 squared. Subtract x squared from both sides. We have the y squared equals 3 squared is 9 minus x squared. Take square root, the y equals the plus minus square root of 9 minus x squared. The length is positive, only choose a positive one. So this y is exactly same to square root of 9 minus x squared. This is the idea. So like this. So we have it like this. Next, you can solve. You plug theta into here. Answer is tangent theta. What's it like a tangent theta? Here. Opposite over adjacent. So we have y over x. What's it like y? Y equals square root of 9 minus x squared. Square root of 9 minus x squared over x. So that's it. This is the whole idea for solving this problem. So like this. Next, we can remind differentiation formula together. Do you know C prime? What is C prime? What is C prime? C is constant. What is constant prime? The zero is right. Zero. Zero is right. Zero is right. Zero. Yep. Thanks. Zero. Yeah. What is x prime? Good. What is x n prime? So we have power rule, is right? Yes. N times x to the m minus 1. CF prime is take out C, C times F prime. F plus minus G prime is F prime plus minus G prime. F times G prime, exactly product rule. F prime times G plus F times G prime. F of G prime is, you can do quotient rule. The top on prime times bottom on minus, top on times bottom on prime over bottom on squared. Sine prime is cosine. Cosine prime is negative sine. Tangent prime is secant square. Cotangent prime is negative cosecant square. Secant prime is secant times tan. What cosecant prime is negative cosecant cotangent. Do you know chain rule? F of g of x prime is f prime of inner function g of x times g prime of x. The power rule combined with the chain rule is g of x to the power n prime is n times g of x to the n minus 1 times g prime of x. The differentiation formula, the more things. So do you remember what's ln of x prime? Do you know? Could you run your answer on the chatting board? What is ln of x prime? All right, yeah, 1 over x. The ln of g of x prime is use chain rule, g prime of x over g of x. Do you remember log x with base a prime? What is the answer? What is the answer? 1 over x times ln of a, you're right, good. So in this case, you can use change of base. The log x with base a is exactly same to ln of x over ln of a. You can take a derivative to both sides. So what happens? You can take out constant ln of a, just ln of x prime. So we have 1 over ln of a times 1 over x, exactly 1 over x times ln of a. Yeah, this is like idea. So we have it like this. E to x prime is e to the x, e to the g of x prime is chain rule, e to the g of x times g prime of x. Do you know a to the x prime? What is a to the x prime? So could you write your answer on the chatting board? What is a to the x prime? Do you remember? Is it right? A to the x times ln of a. Is it right? Is it right? It's good. A to the x times ln of a. So a to the g of x prime, chain rule again. A to the g of x times ln of a times inner function g prime of x. Inverse sine of x prime is 1 over the square root of 1 minus x squared. Inverse cosine of x prime is minus 1 over square root of 1 minus x squared. Inverse tangent of x prime is 1 over 1 plus x squared. Inverse cotangent x prime is minus 1 over 1 plus x squared. Inverse secant x prime is 1 over x times square root of x squared minus 1. Inverse cosecant x prime is minus 1 over x times the square root of x squared minus 1. You need to memorize this whole rule. So next, we try to solve this problem. So what's that? The first one, you have to use product rule. So what's the product rule? First one, prime, times second one, plus first one times second one prime, minus 5x prime. You can use all rules. X prime is 1 times ln of x, plus x times ln of x prime is 1 over x minus. What is a 5x prime? Could you write your answer on the chatting board? What's a 5x prime? Is it 5? It's good, thanks. This is like 5. So simplify. X is crossed out. This is ln of x plus 1 minus 5. 1 minus 5 is 4. Ln of x minus 4. So that's it. This is the whole idea. G prime of x was like the best way. Not yet. This is like 2 is like down. 2 is like down. You can change it. The 2 times ln of sine of x prime. You can take out 2. We have 2 times ln sine of x prime. So what's that? This is 2 times, you can use chain rule, sine of x prime over sine of x. So 2 times sine prime is cosine, sine x. So do you know identity of cosine over sine? What is cosine over sine? What is identity of cosine over sine? Do you know? Yes, cotangent. This is the idea. So one more. So another function is like g of x is the another one. We have ln of sine of x whole squared. So this case, how can you find derivative? This is totally different. So one thing is, don't take out 2. Don't take out. You can keep. You can use power rule. 2 times ln of sine of x to the power 2 minus 1. Power rule times inner function prime. Inner function is ln of sine of x prime. So this is the same to 2 times ln of sine x prime is just ln of sine of x times ln of sine x prime is exactly sine x prime over sine of x. 2 times ln sine of x. This whole thing times sine x prime over sine x is here. Cosine x sine x, cotangent x. We have cotangent x. You can interchange cotangent and ln sine. 2 times cotangent x ln of sine of x. This is like answer. Really be careful. So power is like inside and the outside. We have a totally difference. Really be careful. So these are 2 kind of problems. The next tip. So we think about h of x. H of x is arctangent e to the 3x prime. The first one, arctangent is outer function, e to the 3x is inner function. What's it like arctangent of x prime? Arctan x prime is 1 over 1 plus x squared. So what's that? 1 over 1 plus, you plug inner function into x. So we have e to the 3x squared times e to the 3x prime. This is like a whole idea. The next is 1 over 1 plus e to the 3x squared is 3x times 2 is 6x. The e to the 3x prime is e to the 3x times inner function power prime. So we have 1 over 1 plus e to the 6x times e to the 3x times 3 and combine. So this is exactly 3 to the e to the 3x over 1 plus e to the 6x, right? You can combine. This is like only 3 combine going to numerator, like this. Next one, find the first derivative of f of x log 3 arcsine of root x. So how can you find this one? So what's step 1? We can use this rule. Change of base. Log of x with base a is same to what? The ln of x over ln of a. This is the idea. You can change it inside on first before taking derivative. So one more. ln of 3 is constant, take out. Only ln of arcsine of root x prime. So what's that? The arcsine of root x is like inner function, log of g of x. So we have arcsine of root x prime over arcsine of root x. So what is it like arcsine root x prime? So I can write here. Arcsine root x prime is so like this. So I want to use this one. So do you know this one? Arcsine of x prime is 1 over square root of 1 minus x squared. You can plug root x into x. So we have, this is 1 over ln of 3 times, you can use arcsine root x times arcsine root x prime is 1 over root x into x, the square root of 1 minus square root of x squared times inner function prime. So like this. So we have it. So like this. Next, what's like the root x prime? The square root of x prime is, do you know what's that? What's the square root of x prime? Could you write your answer? The square root of x prime on your chatting board. So what's your answer? So what's like a square root of x prime? 1 over 2 square root of x is right. It's good. This is exactly 1 over 2 times square root of x. So we have it. You can just simplify. The ln over 3 to combine into here. The square root of x is here. The square root of x squared is only x. The square root of 1 minus x is here. Last one, arcsine root x here. That's it. This is the whole idea for solving this problem. The next tip. How can you solve this problem? This one, we can use this rule. A to the g of x prime. This is the formula. A to the power g of x times ln of a times g prime of x. So this is what? Exactly 2 to the x cubed plus 1 times ln of 2 times x cubed plus 1 prime. So simplify. 2 to the x cubed plus 1 times ln of 2 times x cubed plus 1 prime is exactly 3x squared. So the 3x squared ln is going to front is better. So we have 3x squared times ln of 2 times the 2 to the x cubed plus 1. So we have it like this. Is right. This is like 3 times ln is first x squared 2 to the x cubed plus 1. So what you like a second derivative? You can take out constant. You can use product rule. So we have 3 ln of 2. So here x squared prime times 2 to the x cubed plus 1 plus x squared times 2 to the x cubed plus 1 prime. We can use product rule. So what's x squared prime? X squared prime is 2x. What's 2 to the x cubed plus 1 prime? Do we have it? You can use this procedure. Do we have this result? Exactly, this one is 3 times ln of 2 x squared 2 to the x cubed plus 1. You can plug this one into here. So we have it. The next simplify. Here, this is take out 3 times ln of 2. The x squared times x squared is x to the 4. The remaining part is here. This is like a whole idea. The next one, logarithmic differentiation. So the logarithmic differentiation is used for finding derivatives of the complicated functions involving the product, quotients, or powers, or f of x equals g of x to the h of x. Base is a function, power is a function. Usually we use logarithmic differentiation. Example, the next one. So this is what? Exactly product, quotient, powers. So we can use logarithmic differentiation. Second one, same. Quotient. This is a change to the 2x minus 1 over 2x plus 1 to the power 1/2. We have powers. We can use logarithmic differentiation. Third one, x squared plus 1 is exactly base is a function, power is a function, so we use logarithmic differentiation. This is the idea. How to find? You can follow these steps. Step 1, take natural logarithms of both sides of an equation y equals f of x and use the laws of logarithm to simplify. Step 2, differentiate implicitly with respect to x. Step 3, solve the resulting equation for y prime equals f prime of x. So that's it. This is whole procedure for solving this problem. We can try to solve these two problems, this one and this problem. Here, step 1, take ln. ln of f of x equals ln of the square root of 2x minus 1 over 2x plus 1. The next is change power form. The ln of 2x minus 1 over 2x plus 1 to the power 1/2. Power 1/2 is down. 1/2 times ln of 2x minus 1 over 2x plus 1. You can change the quotient form to the difference form. 1 over 2, ln of 2x minus 1 minus ln of 2x plus 1. This is step 1. Step 2, take derivative, the both sides. Take derivative, the both sides. What is ln of f of x prime? This is same to f prime of x over f of x. equals keep 1 over 2. So this one, what is ln of 2x minus 1 prime? So do you know answer? Could you write your answer on the chatting board? What's ln of 2x minus 1 prime? What's that? Is it right? The 2 over 2x minus 1? Yes, exactly. Here, this is the same to here, 2x minus 1 prime over 2x minus 1 is 2 over 2x minus 1. Yes, we have 2 over 2x minus 1. Minus ln of 2x plus 1 is prime is exactly similar. Change it plus, 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 plus. So we have 2 over 2x plus 1. The next distribute 1 over 2. What happens? 2 is crossed out. So we have f prime of x over f of x is 1 over 2x minus 1 minus 1 over 2x plus 1. This is exactly step 2. Step 3. So we can multiply the both sides by f of x. Is right? It's like multiply by f of x, the f of x. So f of x is crossed out, you plug. This f of x is original one. The final answer is f prime of x equals the square root of 2x minus 1 over 2x plus 1 times 1 over 2x minus 1 minus 1 over 2x plus 1. That's it. This is the whole idea for solving this problem. Next one, differentiate y equals x squared plus 1 to the power x, the same. So we can use logarithmic differentiation. Step 1, take ln. ln of y equals ln of x squared plus 1 to power x. Power x is down, x times ln of x squared plus 1. Step 2, take derivative. The left-hand side prime equals right-hand side prime. So here, what's that? Same. Y prime over y equals, you can use product rule. X prime is times ln of x squared plus 1 plus x times, we have ln of x squared plus 1 prime. So x prime is 1, exactly ln x squared plus 1 plus x times, this is, what is this one? This one is x squared plus 1 prime over x squared plus 1. X squared plus 1 is only 2x. X squared plus 1. So we have 2x over x squared plus 1. So what's that? We can write right-hand side equals, what's that? ln of x squared plus 1 plus here. So x times 2x is 2x squared. 2x squared over x squared plus 1. So step 3. What's like step 3? The third step is solve this equation for y prime. You can then multiply the both sides by y, crossed out. So this is the final answer. Y prime is, what's like y? You can plug original one into y. So x squared plus 1 to power x times ln of x squared plus 1 plus 2x squared over x squared plus 1. So that's it. This is the whole idea for solving this problem. This is like logarithmic differentiation. The next tip. This last part is like integral. So you can memorize this one. So to remember, what is integral k dx? Could you write your answer? What is integral k dx? So what is the answer? What is integral k dx? So do you know answer? X. So one example is here. What is integral 5 dx? What is the answer? Answer is yes. The same. Plus c. We have kx plus c. This is like idea. Kx plus c. Integral x to the n dx is use power rule. 1 over n plus 1 times x to the n plus 1 plus c, and is not equal to minus 1. So do you know what is integral 1 over x dx? So could you write your answer? What is the integral 1 over x dx? I don't know x plus c, is it right? I don't know x plus c. Is it right? So what do you think? I don't know x plus c. So really be careful. Here, absolute value. Add up absolute value of x plus c. The integral g prime of x, g of x is, you can use here, u equals what? G of x. You can use the substitution rule. du equals g prime of x dx. You can change it. Integral g of x is u. G prime of x dx is here, du. This is same to add up absolute value u plus c. You can change back. Add up absolute value of g of x plus c. That's it. This is the whole idea for solving this problem. Like this. So one more. What is the answer? So what is the answer? Was integral 1 over 2x plus 1 dx. So what's that? Do you know the answer? What's the coefficient of ln over 2x plus 1? Just 1? Only ln over 2x plus 1 plus c? Is it right? Is it right? So really be careful. But here, the 2x plus 1 is, this is g of x. What is g prime of x? The 2x plus 1 prime is 2, but numerator is 1. How can you change g prime of x? Change it 2. How can you do that? Multiply by 2, divide by 2. So we have keep 1 over 2, add up absolute value of 2x plus 1 plus c. So really be careful. This is the idea. Is right? Here, be careful. The integral e to the x dx is e to the x plus c. E to the kx dx is, what is the answer? What is integral e to the kx dx? So do you know integral e to the kx dx? Do you know the answer? So could you write your answer? Integral e to the kx dx? You're right, e to the kx over k dx. So one example is integral e to the 5x dx is, answer is 1 over 5 e to the 5x plus c. So really be careful. This is the answer. What's integral a to the x dx? Do you know? What's integral a to the x dx? So could you write your answer on the chatting board? What's integral a to the x dx? Yeah, right. A to the x over ln of a plus c. So really be careful. This one. Integral sine x dx is negative cosine. Integral cosine x dx is sine x plus c. So integral secant square of x dx is tangent x plus c. Integral cosecant square of x dx is negative cotangent x plus c. Integral secant x tan x dx is secant x plus c. Integral cosecant x cotangent x dx is negative cosecant x plus c. So remember, what's integral tangent x dx? Do you know what is integral tan x dx? So could you write new answer? What's integral tan x dx? It's good. Add up absolute value of secant x plus c. Integral cotangent x dx is very similar. Add up absolute value of sin x plus c, but you don't need. You don't need it. Integral secant x dx is add up absolute value of secant x plus tan x plus c. Integral cosecant x dx is add up absolute value of cosecant minus cotangent, you don't need. Integral 1 over square root of a squared minus x squared dx is inverse sine of x of a plus c. Integral 1 over a squared plus x squared dx is 1 over a inverse tangent of x of a plus c. We have these whole rules to memorize. Next, you try to solve this problem. How can you solve? Do you know any idea? Could you use a formula? The integral formula is possible or not? The 1 over square root of x times square root of x plus 1 dx, we don't have a formula. U substitution is possible? U substitution is it possible or not? What do you think? U substitution? Is it possible? U substitution is possible? Okay, what is U? Yes. What is U? The U is, yes, square root of x plus 1. What is U? The square root of x plus 1 prime, the 1 over 2 root x dx. Is right here. This is exactly the root x plus 1 prime dx, exactly same to 1 over 2 root x 1 prime is 0 only dx. So we have it. The next, the multiply the both sides by 2 is crossed out, only 2 du equals 1 over root x dx. So we have it. The next, substitute. Integral 1 over. The square root of x plus 1 is just u here. The 1 over root x dx is 2 du. Next, you have to change lower limit, upper limit. You plug a lower limit into this x, g of 1. Plug a 4 into x again, g of 4. So like this, g of 4. The next, was it like a g of 1? So you plug 1 into here. The square root of 1 plus 1 is 2. The g of 4 is plug 4 into same x. The square root of 4 plus 1 is 2 plus 1 is 3. You can change it to 3. It's the same to what? Integral 2, 3. The take out 2, 1 over u du. So we have it. So like this. Next, find antiderivative. Integral 1 over u is ln over u. 2 times ln over absolute value of u, 3 and 2. You plug 3 and 2 into here. The 2 times ln over 3 minus 2 times ln over 2. So 2 is going to power. This is ln of 3 square, ln over 2 square. Same to ln over 9 minus ln over 4. Combine ln of 9 over 4. Next one. How can you solve this problem? Integral from 0 to pi over 2 cosine x over e to the sine x dx. U substitution is possible? U substitution? Is it right? Yes. What is U? What's U? Yes, sine x. The du is sine x prime, dx is cosine x dx. Next, substitute. This is same to integral. The sine x is here, u. So we have, this is e to the u here. Cosine x dx is du. So like this. You plug 0 into here, g of 0. You plug pi over 2 into here, g of pi over 2. Here, integral, what is like g of 0? Plug 0 into here, sine of 0. What is sine of 0? Do you know sine of 0? What is sine of 0? Could you write the answer on the chatting board? What is sine of 0? Yes, this is 0. You plug pi over 2 into x again, sine pi over 2. What is sine pi over 2? Yep, thanks. The 1. This is 1 of e to the u is u to the minus u du. So how can you find the antiderivative? Here, k is minus 1. You plug minus 1 into k. Okay, you can use this rule. Exactly the 1 over minus 1 e to the minus u from 0, 1. Same to, this is minus 1 over e to the u. Change to the positive exponent from 0, 1. You plug 1, negative 1 over e to the 1 minus negative 1 over e to the 0. This is minus 1 over e. Change positive. E to the 0 is 1, just 1. Answer is 1 minus 1 over e. So we have this answer. The next one. How can you solve this problem? It's the same. You can use integration by parts. Is it possible? Oh, no. This is U substitution. Is it possible? U substitution. Is it right? U substitution. U substitution. Is it possible? Yes. No. How can you solve this problem? You can use U substitution here. So how can you use U substitution? So like this one, you can change it. 0, cube root of 2, x squared over, you can change 4 plus x to 6 is x cube squared 4. You can change it like this. So u equals x cube, that's inner function. What's it like du? du is x cube prime dx exactly 3x squared dx divided by 3. So we have 1/3 du is x squared dx. This is the idea. You can change like this. So what's that? You can plug u into here. Integral 4 plus u squared. X squared dx is 1/3 du. This is 1 times 1/3 du. Same, plug 0 into here. Exactly g of 0. You plug cube root of 2 into x. Here, g of cube root of 2. Is right? So we have like this. The next, what's like g of 0? The plug 0 into x. The 0 cube is 0. You plug cube root of 2 into here. So we have the cube root of 2 cube. The cube root is gone, only 2. So we can take out 1/3. So we have 1/3 equal 0 to 2, 1 over the 4 plus u square du. So like this. Do we have it? So we can use this rule. A is what? 2. So answer is 1/3, 1 over 2, inverse tangent of u over 2 from 0 to 2. It's the same to 1 over 6. You plug 2 into u, so we have inverse tangent of 2 over 2 minus 1 over 6, inverse tangent of 0 over 2. So what's that? 1 over 6, inverse tangent of 1, minus 1 over 6, inverse tangent of 0. So my question, what is inverse tangent of 1? What's that? What's inverse tangent of 1? Do you know answer? Could you write your answer on the chatting board if you know this answer? What is inverse tangent of 1? Inverse tangent of 1 is like this. You can write angle theta. You can use definition. This is same to 1 equals tangent theta. The which angle has tangent function is 1. The angle theta is pi over 4. So like the idea. So this is same to the 1 over 6 times pi over 4 minus 1 over 6 times what is inverse tangent of 0? Same things. The inverse tangent of 0 is angle theta. You can use definition of inverse tangent. 0 equals tangent theta. Tangent theta equal to 0. Angle theta is 0 radian. So answer is 0. So answer is pi over 6 times 4 is 24. This is like a whole idea for solving this problem. The next one. The same things. You can use u substitution on the first one. What's u of this case? What's u of the first problem? U is, what is u? In this case, we can use u substitution. What is u? 1 over x squared. So no. You can choose u equals 1 plus x squared. The du is only 2x dx, but we have arctangent, so we cannot use. The u is, let me see, what's it like arctangent x prime? What's arctangent prime? Arctangent prime is 1 over 1 plus x squared. So we have it. You can choose arctangent like u. 1 over 1 plus x squared is exactly prime. So choice is arctangent. The du is 1 over 1 plus x squared dx. You can change it. It's the same to what? Integral 1 over arctangent of x is u. The 1 over x squared dx is du. So we have ln of absolute value of u plus c. You can change back ln of the u is arctangent. So we have arctangent of x plus c. That's it. This is the answer. Next one was u of second case. So do you know the answer? What's u? The u is, yes, inverse sine. Yes, inverse sine, because du equals inverse sine of x prime is 1 over the square root of 1 minus x squared. You can substitute. This is same to integral 5 to the power u. Inverse sine of x is exactly u. You plug 5 to the u. So here, 1 over square root of 1 minus x squared dx is here, du. 5 to the u du. You can use rule. Remember, 5 to the u over ln of 5 plus c. You can change back. 5 to the u is sine of inverse sine of x. Inverse sine of x over ln of 5 plus c. This is the idea for solving this problem. The last one. The 1 over x times log of x with base 2 was the best way. So we have some of the general logarithm function in the integrand. The best way is you have to use this one. Change of base. You can change this one to the like this. This is the idea. So we have this is same to integral e. This is e squared 1 over x times log x with the base 2 is ln of x over 2 dx. The same to integral e squared e 1 over this is what x times ln of x over ln of 2 dx. The next reciprocal. The reciprocal of denominator is ln of 2 over x times ln of x dx. So this is ln of 2 is like coefficient, take out the constant. ln of 2 integral e squared 1 over x times ln of x dx. This is the idea. The next thing, how can we solve this problem? We can use the what kind of method do you want to use for solving this integral problem? So what do you think? What kind of method do you want to use? Yes, what do you? U is, yep, it's good. ln of x. The du is, ln of x prime is 1 over x dx. So same to keep ln of 2 times integral. You can plug. ln of x is u into here. The next one, 1 over x dx is du. Next, what's e? You plug e into here, calculate ln of e. ln of e is 1. So lower limit is 1. You plug e squared into x again, ln of e squared. ln is cancelled, only 2. Change. So we have ln of 2 times ln of absolute value of u from 1 to 2. You can plug 2 and 1. We have ln of 2 minus ln of 1. ln of 1 is 0. So this is same to ln of 2 square. That's it. This is answer. So one more. Don't write like this. 2 is down, no. Right? So don't down like this. This is answer. Okay, so this is the all for today lecture. So if you have any question, could you write your question on the chatting board? I'll answer your question. So if you don't have any question, you can leave this live session. So thank you for attending the today lecture. So thank you. Yeah, thank you. You're welcome.